it is often helpful, now not always, remember these are suggestions, not rules. Make the harder side look like the easier side, because what's going to happen today is we will have both sides of the equal sign, which means almost all of your algebra now is opened up to you. Where before today you were trying to do things that were good when there's two sides of an equal sign, but not when there isn't. So now you kind of opened up your bag of tricks a little bit more. Number two is to substitute the basic trig identities to make it look easier. For example, you might have a secant in there. Well, maybe write it as 1 over cosine, because that's kind of like your sines and cosines idea right there. 3-factor or multiply to simplify the expression, whichever way you want to go there. Perhaps if there's something in common, factor it out. Otherwise, maybe multiply something to the other side. Maybe that'll be easier. And multiply the numerator and denominator by the same trig expression. So maybe multiply both top and bottom by sine. And isn't that kind of what we just did on that last one? We multiply both top and bottom by cosine. Okay. So what we're doing now is we're actually verifying that that's true. Here is where it becomes a big pain for me to correct. Because every single one of you could write an acceptable answer right now. You could say that tangent of B equals tangent of B. That verifies that that's true. The left and the right side said the exact same thing. Do the left and the right side say the exact same thing right now? Our goal is to get them to say the same thing. Does that mean it has to be tangent of B equals tangent of B? No. I'm sure it's very possible you could get sine of B equals sine of B at the end of this problem. You'd have to be pretty creative, but you could do it. Okay. So let's take a look at our suggestions. What is number one? Make the harder side look like the easier side. Do you believe either the right or the left looks harder than the other one? I'd say the right side looks kind of complicated. And so I would probably try and make that side look more like the left side. And again, you have a lot of options. It depends on how you want to do it. But let's just say all I gave you was the right side, kind of like for yesterday. If I gave you only that, is there anything you can really see to do right away? Well, again, can you factor anything out? No. Is there a trig function squared? Yes. But is it very helpful to change that one? No. And so probably we're going to take that cotangent squared and we're going to change that. So what I would do is let's just leave tangent of B as it is right now. Let's not mess with it. Let's leave it right where it is. So all I did was wrote that over there. That cosine of B, well, that's really not too intimidating, and neither is that sine that's over there. But I have to take it times whatever cotangent squared happens to be. So here's one of your basic trig identities that they're talking about with number 2. And we're going to write that as cosine squared of B over sine squared of B. And a lot of people are going to probably put what underneath this one? 1. Notice I left tangent. If you want to write tangent as sine over cosine, that is completely your option. It's totally up to you. Now, I would kind of forget if I was doing it. Whenever I see a setup like this, I look at the more complicated part of the fraction. Do you think the numerator or the denominator is more complicated in this fraction? Denominator. So let's leave the numerator alone. You see how I keep always going to the most complicated spot in dealing with it? So let's forget about the cosine on top right now. Is there anything I can do on this denominator which says sine of B over 1 times cosine squared of B over sine squared of B? Is there anything I can do there now? Yeah, okay, I can cancel out this sign with, now be careful, only one of those, right? Does everybody see that? Everybody agree with that? So really now what I have is cosine of B over cosine squared sine. Okay, we can do that. Now, I'm going to write a lot of steps. You write as many steps as you need, and I can leave it up when we're done if you would like. So I see that cosine of B, really, that's still not scaring me a whole lot, but I do have this cosine squared of B over sine of B on the bottom. And I'm trying to divide by that, so why don't we get that out of there by multiplying by the reciprocal? So what am I really going to multiply by here? So we're going to multiply by sine of B over cosine squared of B. Do you agree with that? Is there anything on the bottom anymore? Or is all of this now kind of been flipped for us? Yeah, and so some people like to put 1 underneath this for comfort. A 1. Any misunderstandings of how I got there? How I made that move? So have I done anything so far to change any of the values here? No, I have not done anything that is algebraically unacceptable. I haven't changed any of the values. I've just done algebra. Now what? Cancel what? This one here? With? The 2. And now you have actually 2 options of how to finish this one. Because when you're done, you need both sides of the equation to say the exact same thing. So either you can do this, because what is sine of b over cosine of b? Tangent of b. Or what some people like to do is they leave the right side and they just change this side. So do you see what I said earlier, that most of you could have just written down tangent of b equals tangent of b before we did anything? And that is obviously an acceptable answer. I told you earlier that also sine of b equaling sine of b could be a potential answer to this problem, correct? And all you would have to do is take that one I have on the bottom and multiply both sides by cosine. Would you get sine of b equals sine of b if you did that, if you multiply both sides by cosine? Yeah. So is the final answer really what I'm looking for here? No, because you should know the final answer by looking at the question. You could come up with a final answer. As far as that means, you could say 1 equals 1 for every single one of these if you wanted to. Okay? Because you should be able to get to that if you want, because the left side should be the same as the right when you're done. That's how you verify. Do you understand how this is different from yesterday? That's huge. Here we have 2 sides of an equal sign. Before we only had, well, we didn't have any equal sign at all before. Is this the only way to do the problem? Not even close. Yes? Okay, the question was, isn't it kind of the same thing we did the other day? And yes, it's very close based on the way I did this one. But what some people do is they see that sine of b on the bottom there, and they multiply it over to the other side because they want to. You can do that now. Or some people will multiply both sides by different things to cancel things off. You can do that now. Where before you had, that was not an option. Okay? For example, you could multiply right at the beginning, multiply both sides by cotangent squared to cancel off the cotangent squared that's on the right. You can do that. Okay? Not quite. Not quite. Yes? All right. Well, you got a lot of options. Make the harder side look like the easier side. I mean, you can do a lot here. Or you could factor stuff out if you wanted to. Give me a suggestion where you want to start. Okay, I was told a Pythagorean identity. Because what is 1 minus cosine squared? Sine squared. So you can completely replace the entire right side with sine squared. If you want. You don't have to. I don't know where I'm going with that letter. That has nothing to do with that side at all. But here we got tangent squared, cosine squared. And seeing that we had that good question, I'm going to show you how this is different from yesterday. Could you keep going then and do all sines and cosines and cancel stuff off if you wanted to? Yes. Watch how you could possibly do this one. Here's the change from yesterday. You couldn't do that yesterday. You couldn't just divide both sides by something, have this cancel out, and pretty much be at your answer. Okay. You would have had to have gone the other way. And I can show you that other way if you'd like, but there it is. It's done. Okay? Yes? Most definitely you can get sine squared x equals sine squared x. Very easily. Because as long as your right side and your left side say the same thing and you got there algebraically, legitimately, like you didn't just make it up, you're right. Because right now, Hannah, I could take your answer and divide both sides by sine squared and I would get 1 equals 1.
That's what I got.
Which is the exact same thing as everybody else verifying it. That's how you verify to make the left and the right side say the exact same thing. Okay. That's why there are infinite answers to these problems, which is why I have to correct the work. Okay. Yes? Okay, because your identity says we better do a different color. Sine squared plus cosine squared equals 1. And we subtracted this one over. Gone, gone. I just replaced it with the sine squared. Yep. Because the identity is sine squared plus cosine squared equals 1, I subtracted cosine squared from both sides. So it says now that 1 minus cosine squared equals sine squared. And that says 1 minus cosine squared up there. So I completely replaced it with what the identity tells me it's equal to. Okay? What if you get sine squared x plus cosine squared x equals 1? Write it as 1 equals 1, because your left side does equal 1. Yep. Okay, this one right here is actually very simple. It says to find a numerical value of one trig function of x. Well, I have a numerical value. It's right there. It says 1. Do I have one trig function, though? Now, how many do I have? Well, we better fix that. So I've got sine of x. So what do you want to do? Yeah, how are we going to get rid of secant? Yeah, make it 1 over cosine. That sounds like a good idea. Because you need to have a number in there. That 1 pretty much has to stay. I can't really mess with that. Because it says a numerical value and one trig function. So in other words, this is over 1. I have sine of x over cosine of x equals 1. Have I met the criteria yet? Am I close? I'm very close now, because I'm going to write tangent of x equals 1. It's just giving you more criteria to kind of make you try and hone in your skills a little bit is all it is. And let's take a look at this one and then we're done. Well, does that meet the criteria? Well, we've got 0.06, which is what, 6/100ths? Is that a numerical value? Yeah, some people look at that and they see 3 numbers there and they think that's 3 numerical values. No, that's just a number. All right? And we have to fix it though. And so we're going to probably go this method. 1 over what? Sine equals 0.06. Well, it looks as though I made it worse. Oh, but we can take this. Again, I make this one bigger. So you can flip this up and make it like that, correct? So this is gone, went up there. What? That doesn't even look like anything. My goodness. Well, we still made it worse. Oh, those are gone. And so I'm left with cosine of x equals. Again, all they're doing is instead of saying, oh, just go verify, now they're saying, okay, do this, but you got to leave a number in there.